Imagine a gaming and AI world on steroids where every frame is a stunning neural-rendered masterpiece, and NPCs think like real players. NVIDIA's latest RTX 50 series, codenamed Blackwell, promises just that. Revealed at CES 2025, Blackwell GPUs boast the most transistors and AI horsepower ever put into a consumer card. NVIDIA's CEO Jensen Huang even called Blackwell the most significant computer graphics innovation since we introduced programmable shading 25 years ago. NVIDIA's GPU evolution has been a wild ride. In 2020, Ampere, the RTX 30 series, debuted with around 28 billion transistors in the GA102 chip. 2 years later, Ada Lovelace, the RTX 40 series, exploded to 76.3 billion transistors on a 608mm squared die. Now, Blackwell, the RTX 50 series, pushes that even further. The flagship RTX 5090 features a GB202 GPU with about 92.2 billion transistors on a 744mm squared die, the largest consumer GPU ever. In raw shader terms, the 5090 packs 21,760 CUDA cores versus 16,384 on the 4090, which is about a 33% bump. It also has 680 tensor cores versus 512, and 170 RT cores versus 128. Clock speeds tell a more complex story. The 4090's boost is 2,520 MHz versus around 2,407 MHz on the 5090. So, the 5090's raw FP32 compute is only about 27% higher than the 4090 at 104.8 versus 82.6 teraflops. But there's a twist: tensor or AI compute skyrockets. The 5090 should deliver roughly 1,676 teraflops in FP16 and 3,352 TOPS in INT8, with sparsity compared to 661 and 1,321 on the 4090, about a 2.5 times jump in AI throughput. NVIDIA is betting on this AI headroom to reshape graphics. Memory and bandwidth also leap forward. The RTX 30 and 40 series use GDDR6X up to 23 gigabits per second. Blackwell moves to GDDR7 memory. The 5090 has a 512-bit bus with 32 gigabytes of 28 gigabits per second, GDDR7, compared to 24 gigabytes of GDDR6X at 21 gigabits per second, and a 384-bit bus on the 4090. That delivers around 1,792 gigabytes per second of memory bandwidth, roughly 78% more than the 4090's 1,008 gigabytes per second. In short, the RTX 50's chip is bigger, beefier, and far more memory-rich, designed to handle enormous data and AI workloads. Let's dive into the key spec highlights comparing the RTX 5090 and the RTX 4090. The GPU die size stands at 744 square millimeters, with 92.2 billion transistors for the RTX 5090 versus 609 square millimeters with 76.3 billion transistors for the RTX 4090. In terms of CUDA cores and SMS, the RTX 5090 features 21,760 cores across 170 SMS, while the RTX 4090 has 16,384 cores across 128 SMS. Tensor and RT cores are also upgraded, with the RTX 5090 boasting 680 tensor cores and 170 RT cores, compared to the RTX 4090's 512 tensor cores and 128 RT cores. FP32 teraflops are 104.8 for the RTX 5090 compared to 82.6 for the RTX 4090. Tensor performance in FP16 is approximately 1,676 teraflops, with sparsity for the RTX 5090, which is about 2.5 times the 661 teraflops of the RTX 4090. The RTX 5090 comes with 32 gigabytes of GDDR7 memory, running at 28 gigabits per second on a 512-bit bus, delivering around 1.79 terabytes per second of memory bandwidth. In contrast, the RTX 4090 has 24 gigabytes of GDDR6X memory at 21 gigabits per second on a 384-bit bus, offering about 1.01 terabytes per second. Power consumption, or TDP, is around 575 watts for the RTX 5090, compared to 450 watts for the RTX 4090. Finally, the launch MSRP is $1,999 for the RTX 5090 versus $1,599 for the RTX 4090. Under the hood, Blackwell is designed around AI-driven rendering. Unlike Ada Lovelace, which was optimized for raster and ray tracing, Blackwell's SM, or streaming multiprocessor, is fully primed for neural workloads. Each SM now doubles its integer throughput compared to Ada, allowing twice as many address or logic operations per clock. This is crucial for running small neural networks and shaders. NVIDIA even calls this era neural shading, where you can embed tiny neural networks directly into the graphics pipeline to replace or assist traditional code. The Tensor cores see a major upgrade. Blackwell's 5th-generation Tensor cores introduce FP4, or 4-bit float support, that can double AI throughput while halving memory needs. Data center variants even have new transformer engines with FP8, but even consumer cards benefit. In practice, that means neural network computations, from frame interpolation to texture synthesis, run much faster on Blackwell. NVIDIA's marketing simply says, max AI performance with FP4 and DLSS 4. Ray tracing also gets a boost. Blackwell has 4th-generation RT cores now built for mega geometry. In simple terms, they can trace vastly more triangles and lights per frame. NVIDIA claims up to 100 times more ray trace triangles in a scene. Combined with more ROPs and aggressive clocking, games can push denser scenes with full ray tracing on. In tandem, the GPU uses transformer-based DLSS 4 models to reconstruct and super-resolve the image with more details. NVIDIA even added a new on-chip AI coprocessor, the AI Management Processor, or AMP. This is a small neural engine that can run multiple AI models, vision, language, audio, behavior, etc., concurrently while the GPU is rendering. In practice, this enables things like game NPCs powered by language models, vision and reasoning all on the GPU. All told, Blackwell's feature set includes 5th-generation Tensor cores with FP4 for huge AI speedups, 4th-generation RT cores for mega geometry with up to 100 times more triangles, RTX neural shaders for small AI networks inside shaders, NVIDIA DLSS 4 for AI multi-frame generation with up to 2 times the frame rate compared to DLSS 3, AI management processor to run multiple AI models alongside graphics, next-gen GDDR7 memory for ultra-high speed and efficiency, mega geometry tech to dramatically boost ray trace detail, and Power/Max-Q enhancements for thin and efficient designs with battery life improvements of up to 40% on laptops. Memory bottlenecks have long limited high-resolution gaming and large data sets. Blackwell tackles this head-on. The RTX 50 cards, starting from the 5070 and up, move to GDDR7 memory. Initial GPUs use 28 to 30 gigabits per second. GDDR7 chips, a healthy jump over the 21 to 23 gigabits per second, GDDR6X of the RTX 40 series. For example, the RTX 5090 runs its 32 gigabytes of GDDR7 at 28 gigabits per second on a 512-bit bus, yielding about 1.79 terabytes per second of bandwidth. Even the 5080 uses 16 gigabytes at 30 gigabits per second on a 256-bit bus, compared to the 4090's 384-bit 21 gigabits per second configuration, which did around 1.01 terabytes per second. That's a 33 to 78% increase in effective bandwidth. GDDR7 also brings larger chips, 16 gigabits equaling 2 gigabytes and 24 gigabits equaling 3 gigabytes, and improved efficiency. NVIDIA hinted at future cards with 24 gigabytes of VRAM on a 384-bit bus using 3 gigabyte chips, which could double VRAM capacity for professional use without doubling the number of pins. The RTX 5090 laptop GPU already uses 3 GB GDDR7 dies to pack 24 GB of memory on a 256-bit interface. In short, Blackwell's memory subsystem is wide, fast, and ready to feed those monster shaders and AI models. The hallmark of the RTX 50 series is its AI-driven rendering. NVIDIA unveiled an entire RTX kit of neural graphics tech to leverage Blackwell's strengths. Key elements include neural texture compression, which uses a trained neural network to replace block compression. It can compress thousands of textures quickly, reducing VRAM usage by up to 7 times compared to traditional methods at equivalent quality. Gamers and developers benefit from dramatically lower memory footprints for ultra-high-resolution textures. Neural materials allow complex materials like layered porcelain, woven fabrics, and multi-layer shaders to run in real time. NVIDIA claims up to 5 times faster material processing, making film-quality assets game-playable. Neural Radiance Cache is an AI that learns indirect lighting from path tracing and extrapolates an infinite bounce solution, providing dynamic global illumination with far fewer rays. The result is richer lighting and ambiance without a heavy performance hit. RTX neural shaders is a broad category that means programs can call tiny neural networks during shading. For example, you could ray trace hair and then run it through a neural network to add micro detail or reflections. NVIDIA highlighted RTX neural faces,